So if you observe here, hydrogen will share one electron. Chlorine also will share one electron, because hydrogen, it wants to become stable, it needs to donate one electron, share one electron. Chlorine also, to become stable in nature, it needs one electron. So both, they will start sharing one electron each. So how it will be? So hydrogen atom is smaller and chlorine atom is very big. Keep it in mind, because chlorine is 17 and hydrogen is 1. So what will happen? Hydrogen, it has only one electron. That electron itself, it will put in the sharing. And chlorine is having valency. How many electrons it has? Valency. Valence cell, how many electrons it has? Everybody. 7 electrons. So 6 electrons are represented here. Only 1 electron has been shared, so that they will form H and single bond chlorine. But chlorine, you cannot leave like this. You have to represent how many electrons above the chlorine. You have to represent the 6 electrons. Understanding, everybody? Because that is the remaining electrons. Clear, everyone? All of you? Please respond. But hydrogen not representing. Why? Hydrogen is already how many? Only 1. Clear, everybody? So that 1 itself is shared. So it is not necessary to represent. Clear, everybody? Understand, Mitakshri? Yes? Any doubt? Please ask. Make it. Now, next. Formation of water. So we all knows that. Even this chapter, we have started with one of the bond formation, this one. So water. So if you have taken water molecule, so water formula, we all people knows that. What is that? H2. Am I right or wrong? So what is the atomic number of what hydrogen? 1. So electronic configuration is 1. One cell, single cell, and itself is the valence cell. So how many electrons needed to become stable in nature? Hydrogen. Everybody. It needs how many electrons more to become stable in nature? All of you. 1 electron. Okay. So that 1. So oxygen, what is the atomic number? Johan will say. Of oxygen. Yes. Johan, I'm calling you. Cannot hear. What is the atomic number of oxygen, guys?
8.
So what is the electronic configuration? 2, 6. So K and L. So valence cell is this one. So how many electrons need to become stable in nature? Everybody. Yes, please. 2 electrons. One hydrogen atom can share only 1 electron. So that totally how many hydrogen atoms will come? 2 hydrogen atoms will come. So 1 oxygen atom, all of you check it. 1 oxygen atom will combine with how many hydrogen atoms? All of you? 2 hydrogen atoms. So this is hydrogen and this is hydrogen and this is what? Everybody, oxygen. Understanding? Big in size. So now oxygen totally 6 electrons. So one will share with this hydrogen, another one will share with this hydrogen. Then remaining how many electrons? All of you? How many electrons? 4 is remaining. Am I right or wrong? Everybody? Yes, please respond.
Yes, sir.
Yeah, that 4 will be here. And hydrogen only 1. That 1 will be shared here. So that's all it is. So now if you draw compound, so oxygen, you can check it. So bond, this one pair I will represent here. And this another pair is represented here. So hydrogen. So totally remaining how many electrons? How many electrons is above oxygen? Everybody? 4.
4.
Okay. So 4 you can represent. So this is how the formation of water will take place. Next, formation of ammonia. What is the formula of ammonia? Formation of ammonia. Ammonia is what is the formula? Everybody. Ammonia molecule. Okay. So again same. Hydrogen atomic number is 1. only one shell, K shell. And nitrogen, what is the atomic number? 7. And electronic configuration is 2, 5, K and L. So how many electrons it needs to become stable in nature? Nitrogen. Nitrogen needs how many electrons to become stable in nature? Mr. Pugal?
3 electrons.
Nimish?
3 electrons, sir.
3 electrons. So that, but one nitrogen give only 1. So that totally how many hydrogens we need?
3 hydrogens. 3 hydrogens.
3 hydrogens. That's all. So I will draw. You all see that. First, nitrogen is bigger in size. So with that, now I will draw 3 hydrogen molecules. One hydrogen, another hydrogen, another hydrogen. So this is hydrogen, hydrogen, hydrogen. So each hydrogen will donate how many electrons? Everybody? Each hydrogen donates how many electrons? So donate, not share. 1 electron. And now each nitrogen, each hydrogen, it will share how many electrons? 1 electron. And nitrogen is remaining. So 3 electrons is shared with the 3 hydrogens. Remaining how many electrons extra? Valence shell. Yes, please. 1. Understand? 2. Sorry, 2. So that's all. Now the bond will form like this. So nitrogen, one pair of, this is what we used to call as lone pair of electrons. What is to call? Lone pair of electrons means unshared electrons. How many unshared electrons? Nitrogen. Unshared electrons are how many? 2. So remaining, they will share with the hydrogen. That is what? NH3. 3, how many bonds actually? 3 single nitrogen NH bonds. That is what? NH covalent bonds. Covalent bonds. That is what? How many NH bonds? 3 NH covalent bonds. That all are single bond or double bond or triple bond? Single bond. Okay. That is. So that is how the N and nitrogen and hydrogen become stable. Next. Last compound in this. So formation of, you can form many compounds, whatever you want. Formation of C2H4. Of course, next chapter also will start with these kind of things only. So many things we will draw there. Everything is structure. Everything is molecule. If you don't know this one, because there everything is sharing only, because it's a carbon. Carbon and its compounds. Chapter name itself, carbon and its compound. So what will happen? Everything is a covalent bond, covalent compounds or ionic compounds. Carbon and its compounds means everyone. All are covalent compounds. So everywhere, what is that? Sharing of electrons only. So everywhere it is sharing of electron. Everything will come into the account. So please make it now. Formation of ethene. All of you right. Formation of ethene. What is the formula of ethene? Everybody? C2H6. So first one carbon. So one carbon, what is the atomic number of carbon? Everybody? Yes, please. 6. So 2, 4. So to become stable in nature, how many electrons is needed? Valence shell. How many electrons is needed? 4 more electrons. Next, hydrogen. So we all know that hydrogen is only 1. So how many electrons it has? Only 1 electron. So now, all of you check it. C2H4, it is same. So let it be. First I will draw. Formula, you know, you can draw the structure easily. So first tell me how many carbon atoms? How many carbon atoms? Fastly. How many carbon atoms?
2 carbon atoms.
2 carbon atoms. And how many hydrogen atoms? Formula. 4 hydrogen atoms. Understanding?
4
hydrogen, 2 hydrogens, 3 hydrogens, and 4 hydrogens. Over. So this is hydrogen. You fix it first. Hydrogen, hydrogen, hydrogen. Hydrogen, any extra lone pair of electrons? That is what my question. Is there any extra lone pair of electrons for hydrogen? No. Yeah. So each hydrogen will share 1 electron. Okay. And each carbon also will share 1 hydrogen. Let me make with another color so that one electron with each hydrogen, so that each carbon already 2 electrons has been shared. Then how many remaining? How many remaining? Yes, please. Remaining 2 electrons. That 2 electrons has been shared between. So what is the lone pair of electrons for carbon? Anybody? What is the lone pair of electrons for carbon? Who is that? Sira, mute yourself. Disturbance. Mute and you can speak. So what is the lone pair of electrons for carbon? Anybody?
No.
No lone pair of electrons because all four are there, all four are shared. Is it okay, everybody? Yes, please. That is what. So between them it will form double bond. So this is what? Double covalent bond. Double covalent bond, and each hydrogen it will form what? Single bond. So this is how the structure will come. Is it okay, guys? All of you? So how many single bonds are there? 4 single CH covalent bond. Understanding, Mitakshri? Abhirami? 4 single covalent CH covalent bonds and one double bond, one C double bond C, one double bond, not single, one double bond, CC double bond, CC double bond, one CC double bond. That is what is the number of bonds. Also we have to count. In the next chapter it will come. That is what I am saying. I hope you all understand. Everybody clear? Anything down? Please let me know. So this is how you people will draw the formation of covalent compounds. Understanding, all of you? So this is anybody having doubt, you can ask me. So this is how you have to make it. You can form any other compounds. If you want practice, you can take 2 more, 3 more compounds and you can start draw. If you draw, then definitely it will be more easy for you to make it. So that's what. Unless you make more practice, you people cannot draw these compounds. It's not easy task. It's very, very tough. So please kindly go through everything unless you have a clear idea. That's why I said minimum how many elements you have to learn? Minimum 30 elements. Each and every one need to learn minimum 30 elements. If you don't know 30 elements, it is impossible to make it in exam, I'm saying. You need to know electronic configuration, atomic number, and each and everything regarding at least first 30 elements. Remaining, if it is comes, what we can do? We cannot do anything. So please kindly understand that and try to make it. So there is nowhere gap. Learning gap has to be never encouraged. Please kindly learn. As I said today, you have to learn by this time. 3 days before I said learn 30 elements. I don't know. Many people are still they are not showing the interest. So that's what it is. Then I will send you the properties of covalent compounds in the group. Just have it and just list it. And then tomorrow we are going to start occurrence of metals. So till here almost 70% of chapter is over. But till here there is a possibility of getting 1 or 2 mark in our board exam. But the next concept, occurrence of metals, the ores and their extraction process and all, 100% minimum 2 mark guarantee question will come. Because many things will come after this only. Okay. So with this I leave. I'll give you the properties of ionic compounds. It's fully theoretically only. So that properties alone, please learn and write in our classwork now itself. So I'm expecting everybody will get back to the work and will start reading. So with this I'll stop, and then tomorrow we'll go with the occurrence of metals. Okay. Thank you everybody. We'll meet tomorrow. Please get back to the work and learn 30 elements kindly. Okay. Start reading now. Thank you.